Hello, welcome back to my channel Study with me. This time I will explain subtopic structure 1.3.3 to structure 1.3.5 about electron configuration under structure 1.3 theme 1. Please join my WhatsApp and Telegram channel as I'm planning to create a dedicated IB chemistry community where we can have live classes, a place for you to post your questions, and I will work through them with you. Once we have a good number of students, I will officially launch the community. And also please share this channel with friends who are also studying IB chemistry. The more students who join, the more opportunities we'll have to grow and support each other in our studies. From these three subtopics, you need to know how to deduce the maximum number of electrons that can occupy each energy level or main energy level with symbol N that can hold a maximum of 2n squared electrons. Also, you need to know how to recognize the shape and orientation of an S atomic orbital and the 3p atomic orbitals. So we will talk about the SP, DF sublevels also of successively higher energies. And you need to know how to apply the Aufbau principle, Hund's rules, and Pauli exclusions principle to deduce electron configurations for atoms and ions up to Z equals to 36. And full electron configuration and condensed electron configuration using the noble gas core should be covered as well. We also cover orbital diagrams and also the electron configuration of chromium and copper. Main energy level, the symbol is N. Here, potassium atomic model with the electron number of 19. So this green dot represent the electrons of potassium. It has 1, 2, 3, 4 shells and 1 electron on the last shell as a valence electron. Alright, so when we talk about shells, this is also represent the main energy level. So the main energy level of potassium's 4. The first main energy level can hold 2 electron maximum. The second one 8 electron. The third one is 18, fourth 32 electrons, and fifth 50 electrons. But here on the third shells or the third main energy level, only 8 electrons. Okay, first let's talk about the electronic structure of potassium with the electron numbers of 19. So the electronic structure is 2881 based on the atomic model. But if we follow these rules, that would be 289, right? So only 3 shells should be like that. But for the potassium, the case is different. The third main energy level, which is N or shell, can accommodate only 8 electrons due to the stability. So this case usually happens for the elements on the third period. Alright? Now let's talk about the sub-levels. So within any main energy level or shell, the ordering of the sub-levels is S, P, D, F, where F has the highest energy. So here you can see 4S has lower energy compared to 3D because 4S is further away from the nucleus, and 4S where the electrons can be easily removed compared to the one that in 3D. And when fill up the electrons, also we start with 4S compared to 3D. We will talk about this more clear when we when we write the electron configuration. Okay, so every main energy has sublevels. So the first main energy level has S sublevels, which is 1s, and for S it can hold 2 electrons, P 6 electrons, D 10 electrons, F is 14 electrons based on this, right? So the first energy level, it has sublevels S, so it has 1 orbitals. Okay, an orbital is a region of space in which there is a high probability of finding an electron. It represents a discrete energy level. So there are 2 electrons can be here. When you fill up the electron, we have to fill up like this way. So it's half number 1. Okay, like this, but not like this. All right, so this one pointing up is positive and pointing down is negative. So this way, 1 orbital, there's the box. All right, it can only hold 2 electrons. So the one is pointing up, the other one pointing down, and half number 1. So for the first main energy level, only 2 electrons, because it has 1 orbitals only. And for the second main energy level, we have S and P. So P has 3 orbitals. So for the second main energy level, it has 4 orbitals, 1 from S and 3 from P. So it has, and P can hold 6 electrons. Okay. So how many electrons on the second shells? It's 8 electrons. So from P, it has 3 orbitals, so this 6 electron, and this one 2 electrons. So let's go back to here. That's why here is 8 electron. And what about 18? Okay, so for the third main energy level, now we've got D. D, it has 5 orbitals. Okay, so the electron would be 10. Okay, so this one 10 electron, this one 6 electron, and this one 2 electron, because S 2 electrons only. P orbitals 6 electrons, and then D orbitals 10 electron. That's why total is 8 electrons, like in here. Okay, so the main point here, you need to know, for the S sublevel can hold 2 electrons, P 6 electrons, D 10 electrons. Okay, and as it has 1 orbitals, P has 3 orbitals, this is consistent also. And D has 10 electrons, 5 orbitals, and F has 7 orbitals and 14 electrons. Right. So about orbitals, how to draw, you only need to know the shape of an S and P orbitals only. Okay, so for S, it's just circle like this. And for P, we've got PX, PZ, PY. So it depends on the axis. For example, if PX, then the P orbitals is on this line. And if it's P Y, here is Y, so the orbitals will be here. And for PZ, okay, here Z, this would be dp orbitals. All right, now let's talk about the rules how to fill the electrons to the orbitals. So when we fill the orbitals, the electrons, okay, into the orbitals, you can't do this way, not this way. For example, there are 4 electrons, so we can't do this way, but instead you go until this box first and then go right here. Okay, so make sure that you fill up each orbitals first for with the electron, and then you go back here with the different direction of electrons. In case of d orbitals, so you will do this way. Okay, right. So now the electron configuration here, So 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so this is the sequence, this is the order: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay, I will tell you the easier way. We can use the periodic table. So 1s2. Okay, so this is S blocks for the first and second elements. Okay, metal, and then P blocks for non-metal, D block for transition metal. So this is period 1, right? Okay, period 1. So 1s2, 2s2, 2p6, 1 2 3 4 5 6, 2p6, and then 3s2. Okay, and then 3p6 and 4s2, 3d10, 1 2 3 4 5 6 7 8 9 10, and 4p6 that way. For example, what is the electron configuration of, here is, that would be oxygen here. Okay, oxygen with the electron numbers of 8. So what is the electron configuration of oxygen? 1s2, 2s2, 2p4. Okay, 2p4. So that's how this oxygen here. So with 8, so 1s2, 2s2, 2p4. Here could be FCl, Cl, right? Cl with the electron numbers 15. Okay, so what about the electron configuration? 1s2, 2s2, 2p, 1 2 3 4 5 6, 2p6. Okay, and then we go to the third period, 3s2, and then 3p, 1 2 3 4 5, 3p 5. In case here calcium, okay, we just need to add 3p6 4s2. all right, in case that this one or this one, then we need to add 3d. For example, here we need to add 3d4 after 4s2 and then 3d4. all right, you don't need to memorize the electron configuration. By having the periodic table, you will be able to note this, and by the time that you're doing the electron configuration for many times, this will just stay in your mind. Okay, now let's write the electron configuration of carbon. First, remember, always fill lowest to highest energy first. Okay, orbitals with the same energy level will fill singly first before electrons pair up. This is what I said, like you need to do first each electron, one electron in each orbitals, and then pair them up, and show the opposite spin by drawing different arrows up and down direction. Okay, carbon with the 6 electron number, so 1s2, okay, and 2s2, so 4 electrons. Now we need 2 more, 1 here, 1 here, 2p2. And sulfur 16, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so the electron configuration of sulfur: 1s2, 2s2, 2p6, 3s2, 3p4. Let's go back into the periodic table. Sulfur is right here, right? So 1s2, right? 2s2, 2p6, 3s2, 2p4. The same right here. Sorry. So 3p4. Sulfur is 3s2, 3p, 4. Yeah, not 2. Here 1s2, 2s2, 2p6, 3s2, 3p, 4 here. Na 1s2, 2s2, 2p6, 3s1. Okay, so 1s2, 2s2, 2p6, 3s1. So this is 11 electrons. Right. We can also use the abbreviation using noble gas core. So helium with the electron number 2 electron, so it means we don't need to write this anymore. So we can write the rest of the electron configuration, which is 2s2 and 2p2. Ne with 10 electron number, so we don't need to write this. So you just need to continue with 3s2, 3p4. So the number of electrons that are the same with the one of the noble gases element, you don't need to write it anymore because this basically the same with Ne. Okay, in case of 18, then we can use Ar, argon. So here also 10, right? So we don't need to write 1s2, 2s2, 2p6, but just continue 3s1. Okay, let's continue with scandium. Scandium is 21 electrons. So here we just write the electron configuration here. So this total is 10. And when we add this here, total is 8. So 18. So we need 3 more. Okay, this. So this one 18 is Ar. So we can just write here Ar, argon, okay, with 18 electrons. And we continue for S2, 3D1, okay. Vanadium 23. So we have all of this 18 electrons, okay. So we need how many more? So 18, we need 5 more. Okay, so this 2 and this 3. So Ar for S2, 3D3. Right? So now continue for chromium. Chromium 18. Okay, Ar. So we need how many more? 6 more. Right? 18 and 24. 6 more. So 1, 2, 3, 4, 5, 6. Right. So in writing electron configuration, we do have some terminologies that called half fill and full fill. Half fill, the way how we actually write the electron configuration is more stable than full fill. So half fill is applied in writing the electron configuration of chromium. So 3D here, 4 electrons. So we need to take 1 electron from 4s and write it here. So 4s1 only here. Okay, so this one we remove it here. So the electron configuration of chromium is 4s1, 3d5. So half fill of the d orbitals. This is more stable compared to having 4s2 and 3d4. All right, for copper 29. So this 18, we need 1, 2. So we need how many? 7. So 18. So 29. Okay, we need 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. The same thing with this. We need to remove 1 electron here. So it's full fill, full for the 3D orbitals. All right, so the electron configuration would be AR 4s1 3d 10. These two are the exceptions. So remember, when we write the electron configuration, that it has 4 electrons here, we need to make it half fill, so take 1 electron from 4s, and this one full fill, so take 1 electron from 4s, so this one becomes full fill. This is very important for the rules of when the transition element is able to form colored compound. We will talk about this in another video. Okay, so now here, after we fill up all the electrons, so this 18, and we got 1 2 here, so I will just fill up how it is before becomes iron. Okay, vanadium until here, chromium here, and copper okay, so all of here AR, right, 3 plus, it means 3 electrons are removed, so these 3 electrons are removed. So the electron configuration of scandium 3 plus, the same with the AR, 18 electrons only. And for vanadium 2 plus, we remove from this. Remember when I said about the energy level, sub-level, 4s is lower compared to that 3d because 4s is further away from the nucleus. So when we remove the electrons, we remove the electrons from 4s first and then 3d. Chromium 3 plus, so we remove 1 from here and then 2 from here, so it becomes 3d, 3, 3d, 3 as well here. Okay, and copper, so we remove from here, so it becomes 3d 10 for copper plus 1 because we lose 1 electrons. Let's go back into the subtopics. So how does these are the linking questions. Okay, how does an element's highest main energy level relate to its period in the period number? Okay, so the relationship between an element's highest main energy level and its periodic number of the periodic table is that periodic number of element directly indicates the highest main energy level that is occupied by electrons in that element. So period number is the period number of an element corresponds to its highest main energy level that contain electron. For example, for AR. So AR with the number 18, so is 1s2, 2s2, 2p6, 3s2, 3p6. Right, so here the highest sublevels is P, and then the main energy is 3. So it means they are in the third period. Okay, if it's only stop until here, for example, not here, so it shows 2, it means they are in the second period. Okay, so the next question, what is the relationship between energy sublevels and the block nature of the periodic table? The relationship is based on the arrangement of electrons in an atom and the corresponding electron configuration. So the position of an element in the periodic table reflects its electron configuration and the highest energy sublevels. So that's all for the explanation about writing electron configuration. We've talked about the main energy level and then sublevels, SP, D, F, and then how to write the electron configuration, where you can also get help from the periodic table, and then for the divisions, S block, D block, and then P block. And then also we talk about the half fill and then full fill rules. All right, so thank you so much for watching, If you haven't already, please subscribe to the channel and do not forget to share it with friends who might benefit. Be sure to join the WhatsApp and Telegram channels to stay updated about the community, where I plan to hold live classes, answer your questions, and work through IB style exam questions for each topic. Your support means everything's for me. See you in the next video.